Hello, my name is Gennady Staskevich, and I will be presenting a review of segment routing. Here's the outline of the presentation. First we'll do background, and then we'll get into the design, and there's going to be a use case and a discussion, followed by discussion. Segment routing. Essentially, it's a next-generation routing technology for large networks. And what do we mean by that? Is that by large networks, we mean such as autonomous systems. A brief overview for segment routing. In 2012, in October, Cisco hosted a conference. It's not a public conference. Segment routing was introduced by Clarence Phills. Shortly afterward, in March at MPLS World Conference, Clarence Phillips presented a first public release of segment routing. He also released a working code and a first use case, and immediately followed by two IETF drafts. In July of the same year, the supporting IETF was released with the focus on interoperability and standardization, and the main objective or the key target was network operators. And at the same time, they released an 8th IETF draft. And IETF is the standardization body. In November of the same year at MPLS, released an automated topology-independent LFA protocol with code. This protocol essentially gave the protection properties for the LDP and eventually IP traffic, and we'll see an example later. So this protocol gives a very fast recovery under 50 milliseconds per prefix. So it's figures out optimal routing paths. Okay, in 2014, in July, many more use cases were added, and these use cases required minimal or only few modifications to this segment routing paradigm. So this shows that these core set of features were a really good set, and minimizes, or at least it was chosen correctly. Again, in December of 2014, it was the first year anniversary, official anniversary of the segment routing, and more material was and use cases were added. So before we dive into the segment routing, let's briefly review some of the terminology. So source routing is a packet routing scheme, essentially allowing a sender of a packet to partially or completely specify the route that the packet will take through the network. Another name for this is path addressing. A label is essentially it's that mechanism that source routing uses to forward flows through the network. So so for the source routing, it uses labels to pass or route packets to correct routes without any additional processing of packets, so they can do it at line speed. IETF is the Internet Engineering Task force. It is a working group for internet-related standards. LDP is Label Distribution Protocol. This is one of the most common methods used for assigning labels for these nodes within an autonomous system. MPLS is a multi-protocol label switching. It's basically it's a scheme, protocol agnostic scheme, label-based routing, and basically it's an ordered list of segments represented as a stack. And segment routing utilizes this for the forward propagation of packets. IGP is the Interior Gateway Protocol. It is used for exchanging routing information between routers within a single autonomous system. Large networks. So the background to the segment, or the need for this segment routing, is that large networks such as in autonomous systems are growing at rapid pace in both size and complexity. The problem with that is that they become very difficult to troubleshoot. They're very expensive to maintain, and they're difficult to manage, and they become more fragile the more it grows. So all these factors make it very difficult to deal with the traditional design, the BGP-based internal routing, and because of that, new approaches are needed, because a single failure can cause a domino effect and result in many complications that will take longer to recover, and so on. They're more vulnerable to attacks also, such as distributed denial of service and a host of other negative things due to the increased complexity. So some of the motivations behind segment routing is that for large networks to be scalable and offer efficient routing, they need to be simplified, run as few as possible protocols, have essentially within the core of a network, reduce the need for maintaining state, essentially get rid of unnecessary processing as much as possible. Also, we need to leverage existing infrastructure. Instead of throwing everything out, we need to be able to leverage the what makes sense. So for compatibility, also leverage recent innovations such as software-defined networks, which introduced flexibility, programmability, and abstractness at network layers. Also need to be able to map concepts of flow and to the concepts of segmentations, and map the concepts of segments to paths, and we'll see a good example of such application later on. So the LDP protocol, Label Distribution Protocol, it's somewhat of an older concept, and it has been used also for it's a common protocol used for label based switching, and the problem of the scheme is that traditionally it's been used in a decentralized environment, and it requires that all devices run this protocol to generate names. The problem with this is that it also introduces potential for black hole in the traffic, because IGP, Intergateway Protocol, and LDP are not synchronized. Another problem is that because they're not using a global label space, adjacent routers may come up with different labels to reach the same router. So this same issue is essentially makes it very difficult to visualize the label switch path. Another problem is that this will likely have a potential to impact the recovery after a link failure unless session protection is utilized. So the proposed solution is called segment routing. It's based on or leverages multi-protocol label switching and source-based routing paradigm. The basic idea is to, within an autonomous system, look at centralized control, and it makes sense because within a single autonomous system, even though it may be large, but the nodes are manageable and for maintaining a centralized perspective on routing paths. And having a centralized routes within autonomous system, it becomes you can computing optimal routes and backup routes becomes a much more trivial task, and it's manageable and computationally inexpensive as compared in a distributed case. It doesn't generate nowhere near as much overhead in trying to maintain the states and everything else. Also, another key point to the segment routing is it integrates well with the software-defined networks, and it was designed specifically with network operators in mind. And much of the driven design was use cases were used to drive the design, and this segment routing scheme was being standardized by the IETF, Internet Engineering Task Force Working Group, and it's also compatible with the IPv6 protocol. So some of the benefits that segment routing offers are it allows for scalable end-to-end policies. It is designed for the IP and SDN. It has ECMP awareness. It provides balance between distributed intelligence and centralized optimization. It provides operational simplicity. It has better utilizations of the installed infrastructure thanks to centralized optimization. The simplified routing scheme significantly reduces latency and disjointness of services. It utilizes MPLS to forward packets. Labels are carried by the IGP protocol. Also reduces the need for running expensive BGP within core of a network. So only the ingress nodes are what they do is they assign the routing labels to incoming flows, traffic flows or packets, and once the packet has a label, there is no need for any additional processing. It goes at line speed within the autonomous system. So there is no expensive state or processing that needs to be maintained within the core of the autonomous system. So routing within the network is stateless, using labels. Packets contain a list of segments, and segments are used for routing. So each segment contains an ordered list of instruction. And each segment can represent any instruction. Could be a topological, like shortest path, or a service-based, meaning that quality of service, such as voice over IP traffic, gets lower latency paths. Segments can be global. So any node in segment routing domain, like an autonomous system, understands the associated instructions, or local. Only originating node understands the associated instruction. Every node in a SAR domain has a unique ID called node SID. And an adjacency SID can also exist for locally significant routes. These will be used for generating alternative route paths. And labels can be used to enforce traffic flow through any topological path. So labels offer a very flexible routing environment within an autonomous system. So one of the things that makes segment and routing work is a mapping server. So a role of a mapping server is to position of a mapping. It's compatible to the BGP route reflector. So a mapping server is essentially a control plane mechanism. Mapping server does not have to be in a data path. A mapping server must be resilient. Redundancy should and it can be to provide the redundancy. Mapping servers advertise prefix to SID mappings in IGP traffic, and on behalf of other segment routing capable nodes. Prefix to SID mappings are configured on the mapping server. Role of a mapping client is to receive and parse prefix to SID mappings from the mapping server, and utilize remotely and locally configured mapping entries to construct valid and consistent active SID mapping policy. Nodes that were not selected for the active policy mapping are used to create backup SID mapping policy. And IGP instances in an active SID mapping policy are used to recalculate the prefix SID for all prefixes, so ensuring that we get consistent routes. For example, consider the following traffic. There is a bunch of routers from A to Z, and using segment routing, we'd like to flow data from A to node Z. And in this case, it uses, for example, we pass to the traffic that it has to reach node with SID 100, so at node 8. And based on a routing scheme, we don't have to specify each specific routing path that it has to traverse, but the routing path can default to shortest path, for example. So it will route traffic from A to B, B to C, D to E, D to Z, and the traffic will get there. And this will require that our labels only contain a single label within a segment. For example, a segment, a routing example again from A to Z, but it has a particular path that it needs to follow. For example, data must flow from the source router from point A to but it doesn't matter how it gets it, but it must get to node with SID 200, which is node F, and from there take a specific path, edges 9003, from F to G, then from G to D, and then from D to Z. So the routing our label essentially would contain 4 entries. It would contain the node ID of with SID 200. So we'll take whatever the routing policy, default routing policy from A to F, and from F we'll take a specific policy for routing traversing edges 9003, 9002, and 9008. So this gives another example of very flexible scheme that segment routing offers. So consider this particular example where assuming that the traffic, we have 2 types of traffic going through this system, and on the top we have path A, B, C, D, Z, and that has a higher latency path, but path AEF on the bottom right here has lower latency. And consider the scenario where we have a traffic, for example, that like voice over IP. So we would like to send it to the through the lower latency, because disrupting voice over IP will make it not usable or for the consumers, but the general traffic can flow with slightly higher delay. So one such example is that when the incoming data flows into node A, it can assign labels for voice over IP traffic to flow through this through the low latency path, and everybody else gets treated with a higher latency path. And this is a good example for one of the applications that could be like a software-defined networking scheme, or not necessarily scheme, paradigm. It is possible to program this network to send the voice over data over low latency path and send bulk data over higher latency path, and this would require MPLS TE protocol, as well as keeping state in many devices with a traditional setup. But with segment routing, there is no need to keep the state in the intermediary devices, because the label would provide the proper path for it to follow. Oh, that's too fast. So one of the examples that was presented by let's see, by Clarence Fields at 2014 December at the Open Source Network Summit in December 2014 was let's see, where was this example? Okay, was actual use case that maintained essentially so it was a centralized traffic engineering use case, maintain an up-to-date network model of a very large autonomous or network autonomous system. So the continuously receive policy updates on network topology and traffic matrix, and centralized controller can be configured into 3 modes. It had a planning mode, where a human planner does all the routing, all the work. Then there is a technical on-demand engineering mode, which was partially automated, receive responses to sudden change in the network based on central optimization, and an autopilot mode, which is pretty much technical on-demand engineering mode, but it's fully automated. And this particular use case was focused on a very large data set. It had a large network with 50,000 RSVPT tunnels with thousands of links, and to simulate a simple failure, scenario where there were 72 link failures, and what we seen using the IS protocol, the results showed that there was a massive congestion, and it was the bandwidth was insufficient to reroute the traffic, and it showed that roughly you needed to double the entire network capacity to be able to facilitate this rerouting of data. However, same scenario, if with segment routing, applied segment routing, it easily solved most of the problems, and it actually not only that showed that only 3 links were critical to the infrastructure and show that they were the congestion points, and if they went down, that they would bring down the entire pretty much would cause most of these problems. So we can see that segment routing is really useful to network operators from multiple perspectives. Not only that it solves the routing efficiency issue, but it's also a great tool for troubleshooting the network. Okay, so there is more additional information. So it's an open source software available at the following URLs. They have many examples through the tutorials, and they have many use cases that can be reviewed at, which are presented to the or being collaborated with the IETF working group. So some of the discussions was that typical SDN applications appear to have a lot of overhead, and this looks like a great use case because with typical SDN application is that there is because of all the abstractions and additional layers, there's a lot more processing. But as example, it was shown with quality of service application, which relied basically on forwarding labels through the core of the network, made it extremely efficient, and this might be a great application for software-defined networks. Another where this platform also has potential for developing other software-defined networks, for example, like congestion analysis tools, like distributed denial of service filters. For example, you can have nodes that would look specifically for flows that have distributed denial of service traffic and route them to some node that can clean or drop the traffic that suspected to be denial of service. Also can be used for mobile dynamic routing, for like mobile devices moving across networks. It can be used to efficiently create fast, low latency routes. Another interesting point was the website appeared to have a lot of activity from its original announcement date, which was March 2013, the public announcement, to September of 2015. But after this date, it seems to be nothing is being, or at least the website is not being updated. So that's an interesting thing. How is the Cisco still interested in this, or is there much support from Cisco going into this segment routing? I also looked at Google Scholar for related publications, and there were a significant amount of publications, about 1,400 references from 2016. So it looks like the scheme is definitely gaining a lot of tractions within community, and might be one of the solutions for achieving optimal performance within autonomous system. And questions. If there's any questions, please send them to my email address. Thank you.